Evidence for plate tectonics. Plate tectonics is the idea that there are sections of Earth's crust that move. And that's what the picture is illustrating, that at one time our land masses were pretty much all connected in one giant land mass, and they have since moved apart to the image we're accustomed to seeing today. But they are still in motion, which is what the arrows represent. There's a variety of places we can look for evidence for this, but almost all of it is in the ocean. We see a number of things that happen within our ocean that point towards plate tectonics. The first is what's called seafloor spreading, and this is especially occurring within the Atlantic Ocean. Through satellite imagery and other techniques, we actually know that North America and Europe are getting farther apart. It's not by very much, it's like about a centimeter or two per year, but it is measurable. And so we know that the Atlantic Ocean, for all intents and purposes, is getting bigger, and it is pushing the continents apart. The same could be said for South America and Africa, getting farther apart. So that's one piece of evidence. Another piece of evidence is the ages of the rocks. Now this is on the ocean floor. And we know that at the center of the Atlantic Ocean is a rift. Well, the rocks closest to the rift are very young. As you get farther away, the rocks are old. And they get older the farther away you get. So that's what's illustrated here. Youngest are at the rift, this is the rift, and the farther away you get, the older they get. So that implies rock formation at the rift which would give you the young rocks, and then the rocks move apart to make room for new rocks. So something is making the rocks continuously move outward away from that rift. Then our last piece of evidence has to do with magnetic data. We know that every few 100,000 years or so, Earth's magnetic field flips. Now, this does not mean our actual Earth flips over. It just has to do with the magnetic field. So, right now your compass needle points north. If the magnetic field flipped, your compass needle would then point south. So that's what this means. And when new rocks form, the magnetic field gets frozen into the rock, or at least some remnant of the magnetic field. It's not enough to affect a compass, but it can be measured. And what we find is, near the rift, the rocks have one orientation. A little further out, the orientation flips. Go out a little further, flips again. We see this repeating pattern of the magnetic field pointing in one direction and then the other, indicating that those rocks formed at different times and that the plate is moving, pushing those rocks outward and allowing new rocks to form with whatever the current magnetic field is. So these are all ways we can look at our oceans and tell that parts of the earth, in fact, do move.